Okay, so now let's try to have a look at an example to identify the conjugate acid-base pairs. Here we have nitrous acid HNO2 react with water, and the product is a nitride ion and the hydronium H3O plus. So you can see that this kind of reaction occurs as like a moving story of a proton. So what really happens here? This is the thing. You have the molecule NH2O in this way. And then just imagine like proton, hydrogen, nucleus here. It's just like a grow up person that, okay, it's time for me to move out of the house. So like he will move out, say goodbye to the household. So it seems like, okay, or we can see another way that maybe the house like kick him out, he being kicked out of the house. And then he move out. And when he move out, he was split away from the family, so he could also like take away some money with him. So that's why it's a plus here, and then the house should lose some money. You can see it that way. Good, kind of funny way to remember. Okay, but basically we can see that the whole molecule here kind of donating the hydrogen, and then it just become like this. So this is a hydrogen nucleus, or more accurately like a proton plus. So that's why this one just have the charge be minus here, y minus here. We can see in another way that, let me write again here, that the nitrous acid just donating one proton, it means that it's losing one proton. So now in the structure, there's no hydrogen, no H anymore, right? And also the charge has become negative. So instead of writing in this way with a subtraction, it's not very convenient. So that's why usually we can see that they move this one to the other side, and then the minus just become a plus one. So you can see it's more like a math equation, right? So basically here we see the nitrous acid has donate one proton, then it is called a acid based on the Bronsted-Lowry definition. And then this one is what left, and it just become its conjugate base. We should have another minus here to represent for the negative charge of that molecule. So what really happened here is that you can break the whole reactions here down into two phases. The first phase is that basically the proton here say goodbye. Okay, it's time for me to move out. I'm a crop man now. And then he's moved out. He's moving around until he find another home and he want to settle down with the new family member. So then this molecule kind of accept that proton into its house and forming a new substance. So then this one actually accepting the proton. So how can we call them by the Bronsted-Lowry definition? Yes, it is a base. So here that's the water, O and then 2H, so that H2O. So H2O here accepting the proton, basically it combined with the proton join it, and then it form a new substance here, the hydronium ion. And you can see that this one also have the positive charge from the proton itself. So we can see the water again accepts the proton, it is a base, and then this one is its conjugate acid. So basically you can see this is the general pattern. If it's an acid, giving away one proton, it becomes a base, and that's its conjugate base. And if it's a base, and if receiving, accepting one proton, then it's become an acid, and that's the conjugate acid of this base. So now, again, finally, I just want to point out to you again that the whole reactions here can be broken down into two stages. The first stage is like donating the proton, and then that proton will join the other substance and forming another new substance. So now we just care overall, like a summary of what's going on. So we just care about like what is at the initial from initially what do we have. So we have this substance and we have this substance, right? So that's why we just have the nitrous acid and we just have the water. And finally, what is the final result? Then we have the nitride ion and the hydronium ion. So that's why you can see that basically when they write the reaction, they just write the very initial one and the final ones, but they don't include what's in the middle. And if we can understand, okay, the middle things here, especially the moving story of the proton, then thing will make more sense, right? So now we can easily to fill in the table, right? Basically, if you want to find the conjugate acid, you have to start from the base, and this is the base. So this is the base. In order to become a conjugate acid, we should have more hydrogen. First, now it just have 2, now 1 more, so it should be 3, right? And then the same thing, the other atoms in the molecule, and also with another plus from the proton, because proton have 1 positive charge. And for the conjugate base, it should start from the acid. And acid, what happened? It will donate, giving away 1 hydrogen, 1 proton, hydrogen nucleus. So no more hydrogens here, just NO2. And because 1 positive is lost, so we just have a negative here. So see, that's what it means. So I hope that if you can see the whole reaction here, it's just kind of like a story about the moving out of the proton, the independent proton, then things can help to make more sense. Okay, please let me know if anything unclear. And also in the description, there will be link of these more exercises so you can practice yourself, and feel free to let me know if you have question or some particular example that you want to have a look at. Hope this help. Thank you.